Okay, fine. So we are importing the required package NumPy with the convention NP. NP is a universally used convention name to access the functions with NumPy. Functions and other efficient operations with the NumPy package. So I have imported the package. Then I'm going to create a array, that is NumPy array, using the convention np dot array, right? I can able to view all the available methods, predefined functions by just giving a tab. So I'm just creating an array. So I'm giving np dot array, inside which I have to give the elements one by one, separated by a comma. And it's going to be array elements, right? And then I'm just displaying the array which is created. Now I can able to see that array has been created with set of elements by using this NP convention, which refers to NumPy. Right? This is a simple creation of a array, and it's going to be a single dimensional array. It's a 1D, one dimensional array. I can able to create multi-dimensional array. So I am just showing you to create two-dimensional array with some values on it. So first I have to give the one dimension, that is a set of values for a row, first row. Then that has to be separated with square brackets. Second row values has to be mentioned like this. Then I have to close the parenthesis. If I am displaying the array, then I can able to see there are two. I could able to see two arrays. The error here is, see here, I have missed to represent that these two rows belongs to a same array. If I'm not giving this open and close square brackets for the entire list of values, then it will be considered as separate arrays. So I have to mention that this is a first row and this is a second row by using a square bracket. So I missed it. It is showing an error. So I can able to see that two rows with three columns, two-dimensional array has been created under a name A2, right? So even I can call the values by calling the name. Just by printing the values, I can able to see the values stored in the thing. And it is displaying all the values which is in the array. Even I can call element by element by doing indexing. It's a common term which is used in all high-level programming languages. By just specifying the index, I can able to call the elements one by one. So always indexing start with a 0, right? So it's a 0th index, first index, second index, and then third index. So 0th index is 1, and then third index is 4. Similarly, for two-dimensional array, I have to specify the row and column. It's mandatory. It's mandatory to give rows and columns. Row value and then column value. Row index and then column index. A2 is a two-dimensional array. So what I'm going to give, I'm going to give two values, that is row index and column index, to access the element. So 0th row, 0th column. So 0th row, 0th column is 1 here. Similarly, I can able to access second row, first column. So it's showing array index out of box because I have 0th row, first row. I have 0th column, first column, and then second column. In that case, I could be able to access elements with existing rows and columns. So 0th row and then the first column. The value is 2 here. Okay, this is a simple way to access the array elements. This is a simple way. And here there is a concept called reverse indexing. is exist. What is reverse indexing? See, I have a array called A1. I'm just giving values like this. What does it mean? This means it'll try to access from the end. The accessing will be from here. This is your -1, and this is your -2, -3, -4, and -5. This is what reverse indexing. It's still possible to access the arrays in reverse order. And one more thing, you would have heard about slicing. Slicing. This is said to be slicing, array slicing. What does it mean? I'll be giving the start index and then the end index. From this index to this, the values will be retrieved and that will be displayed. Okay, what time if I'm giving like this? I have here 1 and then 4. So when I try to display this, this is your first index. That is 0th index, first index, second index, third index, and then this is your fourth index. But it is displaying value from here to here to here. And this limit has been taken as n minus 1. So first index, second index, and third index has been taken, and this fourth index is neglected. That is, the limit is neglected. So that is what slicing. And these are all the manipulations that has been made with array. And more than that, I can assign some values. That is, I can update the values which is already stored. For example, I have some values stored in here. A1 of 3 is 4. So what I'm going to do, A1 of same 3 is going to be reassigned with some other number. Now, when I try to access this, this is get updated. So this is one another manipulation with array. This is one another manipulation with array. The same thing can be done with two-dimensional array. So with indexing, I can able to access the elements as like I can even update the values. So this is what the value, actual value stored in the two-dimensional array. 0th row, second column is 3. What I'm going to do, I'm going to give some new value here, and still it is going to be stored in the array. So I have updated. Now I'm trying to display it. So it is displaying the updated value. So these are all the manipulations with single dimensional and two dimensional array. Let me talk about different functions, built-in functions which do exist with array to make you understand this different operations and then efficiency which do this numpy array have, so that you can go with in-depth knowledge with array. Let first you just know about this copy function. What is copy function? So there are so many built-in functions available, but one of them I'm showing here that can make you understand how efficient this numpy array is. First, help is a default command which helps to understand about the existing functions and their characteristics. Okay, so I'm just giving copy. I have a function, I have a array and A1 of copy. Just to understand about this, I'm giving this help. Help will give you all the information of particular class or defined functions. So it will tell what to do, how to define an attribute, and what are all the possible parameters can be passed. Everything is given in detail. So whenever we have doubt about using a predefined functions, methods, attributes, see all the functions and their values has been given fastly. Now I'm going to use this copy function. What is the purpose of copy function? So first, for that, I have a array, simple array A1, right? I have a array A1. What I'm going to do now, I'm just creating a sub-array of A1 with some set of values, say A1 of 0 to 3, right? I'm creating a sub-array. So let me check how many values are here. There are 3 values. And with A1, I have 5 values, right? Now, what I'm going to do, I'm going to update. I have already updated some values. Still, I'm going to update some value with sub-array. Sub-array of 0 index equals to 11. Now, when I try to access this subarray, the value is getting changed. Now I try to access this and this is also changed. But what did I do? I have created a new variable and I have assigned some set of values. Then I'm updating some value with a new array till the changes do exist here. So this is what the memory allocation which is created. So what happens, this values has been stored in a memory, particular memory, and only the pointers to this memory is same as the oldest array. So both the values are occupying in the same memory. Only the variable is different. Only the variable is different. So this is a problem. This is a problem like which do the changes which do exist in a sublist is reflecting in the original array. Okay, actually when I'm creating a new variable, it should be a different memory, but it is not happening. In that case, we can use this copy function. So in that case, I'm creating a copy function with the same array. See, this is a variable. And what I'm going to do, I'm going to copy the array which do exist. Okay, so copy function with any array, subarray or in main array, whichever is preferred to be copied. A1 dot copy. I'm taking the subarray, that will be efficient. Subarray A1 dot copy. So now I try to display this. I have this, and what about subarray? So both are having same value. What I'm going to do, I'm going to update some values here, right? When I try to access this, that is update. What about sub A1? That is subarray of A1. It's not update. So when I use this copy function, I'm actually creating a different memory allocation. If not, same memory allocation is given for both the variables. So that will any changes in the sub list will reflect in the original array. But it is a only way to create two different memory allocations for two set of variables, right? So we have created the array. We have created one-dimensional array, two-dimensional array, and I have shown how to access the elements into one-dimensional and two-dimensional array. Then I have shown you some important thing about this arrays, a copy, and how come copy is different from just assigning the array values. And now I'm going to tell you about reshaping the array. So reshaping is nothing but we are going to change the shape of the array. For example, I have an array, sample array with some set of values, right? Some set of values. Just I'm giving some set of values. Some one-dimensional array with some 1 to 6. I'm just checking what is the, I'm going to check what is the type of this variable which I have created. I'm sorry. It's a numpy nd array, okay? And I have to know what is the dimension of the array. What is the dimension of this array? Dot dim. These are all the predefined attributes. See, all, any, argument max, argument min, so many attributes are there. But this I'm using dim. Dim is nothing but dimension. So which dimension I need to check, which is number of dimensions. So it is going to be one dimensional array. I can create them into a two-dimensional array by using reshape function. So same sample array is going to be converted into two-dimensional array by using the function called reshape. And I'm going to give the rows in column size. I need 2 rows, 3 columns. Now, if I try to display this, see, the same value has been changed into 2 rows and 3 columns. This is said to be reshaping. If I have one-dimensional array with some set of values, still I can able to convert them without reassigning them in the different variable. Okay, that is what reshaping. If I'm doing the same thing, I'm doing the same thing with, I can show you with the different case when it is not working, when it is not feasible. We should be careful enough to give the values here, rows and column values. So if I'm giving like this 4 comma 2 means, sorry, 2 comma 4 means I need 2 rows and 4 columns. It will show you error because for creating this 2 rows and 4 columns, it should have this variable should possess at least 8 variables, but it is having only 6 variables. So there is it is not compatible with the shape and size. So it is showing the error, right? So we should be confident enough to create, that is reshape the existing array with rows and columns, otherwise it will throw error. And finally, arithmetic operations. Arithmetic operations in array. Arithmetic operations are very feasible and easy to carry out with NumPy. Here I have an array. If I need to add all these elements together, what we do, we will be including loops and we will access element by element. Then we add them up. This is the process. But here in NumPy, if I give like this sum of A1, it will add all the elements together and it will return the total. So that much simple it is. That much simple it is. And even this is about a normal array which working in Python. When I am very specific with NumPy, I should have used this I should have used this NP. I have to call this conventional variable, right? And how it is going to be different, the time which is taken to access the array elements is completely different when you are using the normal Python core array and your NumPy array. That is completely different. The time taken and efficiency are different. Okay. But the feasibility, I can able to show that how it is very easy to do arithmetic operation. See, I'm just adding A1 plus 5. What is happening? Each and every element in the array is added with 5 and it is displayed here. And it is displayed here. I don't want to do any looping, condition checking. It is just taking the elements and adding all the values with a 5 individually to each and every element and it is displayed. Similarly, even I can do any kind of manipulations, arithmetic manipulations as such like this. So it is A1 multiplication of 4 and this A1 is multiplied with 4. Each and every element is multiplied with 4 and it is displaying the out. In such a way, it is doing the operation so simple. And we have a power operations in NumPy which allow us to do exponential process. Exponential process, see, it is doing some exponential operations and it is displaying the values immediately. Okay, it's doing it immediately. So this is all about one-dimensional arrays, right? All are one-dimensional array. I have a two-dimensional array. So what I'm going to do, I need to sum up these values. Just I can sum this up with some function. What is happening? All the values are added together and it is displaying the output, right? All the values are added and it is displaying the output. But still I can do some more operations on this by doing row-wise, column-wise addition, row-wise addition. How come it is possible? np dot sum, then I have to mention the name of the array, then I have to specify the axis. Axis value as 0 or 1 depends upon the operation. Now it is a column-wise operation, column-wise sum operation when I mention axis is 0. If I do column that is axis is 1, then row-wise addition is happening and it is displaying the output. So these are all simple arithmetic operations with respect to NumPy. Creation of NumPy and then how to manipulate the values of NumPy. And I have shown you different arithmetic operations, how simple it is carried out with single dimensional array and then multiple dimensional array, right?